So far, we've been talking about the embedded system hardware. What I want to do in this lesson and the next one is talk a little bit about the embedded system software. And then we'll learn a little bit about the machine learning software running on the embedded platform. Now I'm going to focus very much on just the system side of things, not on the modeling side of things. And just kind of give you a little bit of a preview as to what's wrapping the whole embedded hardware in order to make it functional. And with any embedded system, we have two core components. There's the hardware and there's the software. And if you open up the software box, it's usually an operating system, there's libraries, and then you have your application code. And specifically, if you look at operating systems, by and large, you're using running things on Linux or Mac or Windows, and you're probably using one of these operating systems to watch the video. Or perhaps you're on your phone or an iPad and you're watching on a mobile OS like iOS or Android-based device. And the question is, what happens when you go to an embedded system? Embedded systems don't have these kind of rich operating system capabilities. In fact, they tend to be quite lean and mean. And they are embedded operating systems, of course, like the ARM Mbed OS and the FreeRTOS, which raise the level of abstraction and make it easier for users to program and interface with the devices. We still want to keep things lean and mean, so we learn how to program our board with and without an embedded operating system. So when you're dealing with your microcontroller, you're mostly programming it, and writing your code in the Arduino processing IDE. And that's going to be your bread and butter for all the examples that we're going to do. However, I want you to understand what's in that software box. So for example, here at the top, we have the Arduino hardware, which is, a software ecosystem with an Mbed operating system, at the base layer. And the operating system provides a lot of functionalities that I'll show you. On top of that, we have the Arduino, which provides a set of functions and, it has a lot of complexity of the operating system. And then you have the Arduino APIs to interface with the sensors and so forth, so that you can build your tiny TensorFlow Lite micro application. And then when you're writing code, well, that's what you'll be dealing with in terms of building your models. And then you'll be using the IDE and writing your code in TensorFlow Lite micro. And using the micro-specific API calls. We'll go much more into detail in that. But all of this is being orchestrated by some sort of low-level code. For example, the Mbed operating system has got digital interface drivers. It's got the ability to interface with analog and digital pins. It's got timers. It's got a hardware abstraction layer. And so there's a lot of complexity in terms of actually running a microcontroller, all of which is hidden away from you. And so therefore, we have to be very careful how memory is actually being used. Now, of course, when you're developing neural network models, you're thinking about the model size because, well, you're in a TinyML course. In course 2, we talked a lot about model sizes. You did quantization in order to optimize the model from FP32 down to int8, because we said that, it's a 4x reduction in the model size. Well, that's great, but in this course, that's not enough. You need to know more, and you need to know how to optimize, across the system. For instance, in order to run, model, you got an interpreter or a TF Lite micro, which is the actual interpreter that's running under the hood. And so you're going to need a little bit of memory for that. And not only that, you've got, your application code, and that I gave you a screenshot of earlier, through which you're actually writing and interfacing with the TensorFlow Lite micro interpreter, which runs the model. And now all of that's going to need some variables and some temporary state, and that's going to take up a little bit more of memory. And finally, you have your sensors which need to store the data, and so which might actually eat up a lot more memory space because audio and image buffers are relatively large. So keep in mind, that the numbers that I'm showing you here are just hypothetical, but to get the message across to you is that you need to be quite aware and conscious about the memory and how it's getting contributed from these different aspects. So let me give you a real world example. Embedded OS is an operating system, and over time it's been evolving. So there was Mbed OS 2, and I'm showing you, the 2 bars here of how much static RAM and flash the operating system itself is consuming when it's running. Now, with this Mbed OS, on the right-hand side, I'm going to show you Mbed OS, 5. That's an improved version of the Mbed OS. And what you see, both the static RAM and the flash are nearly doubling in terms of requirements. For example, in static RAM, the amount of RAM that's being used has gone up by from 5 kilobytes to 13 kilobytes. And that's more than twice the amount of memory that's needed by the OS. So that might not seem very big, but remember, at least for the Nano, you only have 256 kilobytes. And that's just, now the operating system is taking up, 13 kilobytes. Now, if you look at the Flash, which is, where you actually store your application on, you can see that the operating system in version 2 went from 38 kilobytes to 57 kilobytes. So that's a 1.5x increase in OS 5. The point I'm trying to make is that in addition to focusing on the model, you also need to be thinking about the system. And that's why I want you to understand how the applications are built and so forth. Now, all that said, we'll be focusing on learning how to optimize the whole system through this course. How can I reduce this, for example? One of the key things you have to keep in mind is that the OS 5, for instance, is growing, and you need to understand why it's growing. What are these new features that are coming in? And do we need to do that, use all of them, or can we simplify things? For example, the features and frameworks folder is actually something that's actually not needed for our current applications. There are many unnecessary test tools that are built into the actual Mbed OS. Do you really need it now? Well, that takes up 1 kilobyte of RAM and takes up 8 kilobytes of flash, which is very precious. So if we were to take this out, we save a fair bit of memory. And so for the example here, we've gone down in terms of static RAM usage, and in terms of flash, we've actually cut down our flash usage from 57 kilobytes to just 49 kilobytes. And in RAM, we've gone down from 13 to 12 kilobytes. And that's really important. So the point really is that, ML applications are more than just the TinyML models. You've got to think about the whole system stack, because all of that is going to influence how well you can actually, run the end-to-end ML application. Having a TinyML model will not, get you there directly. And so having a TinyML application mindset, that's what's going to get you there. So in the next video, we'll push things a little bit further in terms of understanding the machine learning software ecosystem before we start building our applications out. And I'll see you there.